I'm going to have fun this time. Welcome, science fans. Welcome, science skeptics. Skeptics are welcome in science because science advances by way of devotion to skepticism. In my previous little rambles, I talked about being thoughtful and about being fact-based. So now I want to talk about science, because science is a process for observing and organizing and understanding facts, and for working with them in a thoughtful way. There are good practices to borrow from science, even if you aren't a scientist. And when we are thoughtful, all of us are, in fact, doing a little science. Science methodically examines stuff we can see, hear, smell, taste, and touch, the real world. Scientific methods, the rules of how to conduct scientific examination of reality, are designed to escape or at least minimize the trap of under-informed opinion by moving stepwise from questions to conclusions via evidence. Partnered with this careful observation and examination are bursts of creative endeavor to conceptualize models and theories to explain and connect observed phenomena. The theories and models are about observable reality, but they themselves are not reality, they are ideas, mental constructs. The outcome is a greater understanding about the real world, ability to forecast real-world phenomena into the future, and spin-off applications, like the device on which you are viewing me right now. Mistakenly, this causes some people to rely on science for the truth, the whole truth, and nothing but the truth. Mistakenly, that in turn fuels in others a mistrust of science, because claims that science is truth fly in the face of constant scientific dispute, disproof, rejection, and replacement. If science is so orderly and methodical and evidence-based, how come it is also so unstable? Science is driven forward by skepticism. Science advances by constantly subjecting its models and theories to testing against the very real-world phenomena they purport to explain. When the models fall short, which happens as our measuring tools and techniques develop, they become ripe for replacement. In an endless dance, theories tie together measured phenomena, and then measured phenomena break apart theories. There's an archaeology to science. Today's scientific truth is built on yesterday's and will in turn serve as the foundation for tomorrow's. In the course of this journey, much of what was or is true, much of what has been concluded by the application of scientific methods will be proven anywhere from a little bit wrong to completely wrong by the application of those very methods. The more we refine our ability to observe, typically with the aid of instruments we build using our prior scientific knowledge, the more we need to update or outright replace our models. Science advances by proving itself wrong, not by proving itself right. You can become a skeptic. That's good. You're in the club. All good scientists are skeptics. They apply their skepticism through the practice of science, not by throwing science and its insights under the bus. If science were to stop evolving on top of its own imperfections, we would have reached the end of the road. We'd have nothing further to learn about the real world, no new horizons to explore, nothing to be wrong about. We'd be know-it-alls, perhaps experiencing some kind of omniscient stasis. I hope to be long gone before then. Millennia ago, we watched the moon as it rose, circled the sky, and set. The sun rose, circled the sky, and set. The stars rotated about the night sky as a set piece. We made measurements of these journeys across our heavens, and from these data we invented a model. The Earth is at the center of things, and the other bodies circle around it. The model provided a satisfactory explanation of the observations. With some math invented and added, we could update and predict the future positions of the sun, moon, and stars. It allowed us to build practical applications like accurate calendars and feel-good factor. This model put our home planet right at the heart of things. Very nice. But better observations began to rattle the model. For example, the observed orbits of the other planets reconcile very awkwardly with the Earth-centric model. New real-world evidence caused the old truth to be questioned, and eventually a replacement model was proposed. The Sun at the center, the planets, including Earth, orbiting it, the moons orbiting planets. This model resolved the observational quandaries. It fit the facts well, does to this day. It's been corroborated by increasingly powerful observation ever since. It is now reality in and of itself. It's become a small part of an expanded model that speaks to the observed galaxy and universe. That model is still evolving. The math attached to it keeps getting refined by new theories that replace old because they are a better fit with observation. Kepler, then Newton, then Einstein, and so on. Two things are going on here. The first is that observations keep getting better. In the case of the solar system and the universe beyond, the invention of the telescope is a case in point. It allows us to discover new phenomena in the night sky and refine the accuracy of observation and measurement. We just launched the James Webb Space Telescope, the latest extension of human sight to the far reaches of time and space. Better facts, better outcomes. The second is that models to explain observations evolve and replace each other as new observations suggest to attentive and creative minds better fitting models. What we are about to observe with Webb might corroborate our current models about space and time, or might help shake them to the core and begin the creation process anew. Science isn't all careful experimentation. It also features world-shattering thought revolutions. Each new model is proven only to the extent that it has not yet been disproven. The old Earth-centric model dominated for at least 2 millennia, so we should not feel completely complacent about the reality or stability of our current model. Hope yet for the Flat Earth Society. Well, not really, because no supporting facts. More models without facts do not make the cut. Models with facts are accepted, but the skeptics are rightly circling to see if that fit remains tight when subjected to further observation. So to turn to current events, what about climate change? There's an annoying accusation that the science of climate change is rubbish because it is under constant revision. Well, of course it is. Climate change science is only about 100 years old. The tools we have to observe climate phenomena are evolving. The very thing being observed, the state of and change in climate, is dynamic and complex. Thank goodness the science of climate change is in flux, or we would now be stuck with some very sketchy preliminary models. Expect the flux to continue, ever better outcomes. So to review, science, beyond measuring things, is about models. Models are not real, they are creative inventions of the human mind that explain reality, help us predict reality into the future, and enable us to develop applications. They are mental tools we have created to help us work with reality. The theory of relativity is exactly that. The fact that science keeps proving itself wrong and replacing itself is no reason to reject it. It is the very thing that makes science credible as a guide to observed reality, a thoughtful guide. Is there bad science? Of course. Do some scientists cheat? Yes. Do some scientists fool themselves into observing exactly what they hope to observe, not what's there? Of course. The reason you hear stories about badly done science or fraudulent results is because good science eventually catches it out. The methods of science help ensure movement towards legitimate results. The method is like a giant positive feedback loop on the quality of the whole enterprise. Don't knock science for getting stuff wrong. Science is constantly getting stuff wrong on the way to getting it right. Celebrate it for being on the path of getting it more right than before. Science is a profoundly thoughtful way to examine observed reality. Slow, methodical, evidence-based, questioning itself, open to change, occasionally revolutionary. But don't take it from me. I ain't no scientist. Please experiment and draw conclusions for yourself.